Hi all, welcome to Unit 3, Lesson 5. Our topic today is trigonometric identities. So for the warm-up, I want you to pause the video and try it on your own. So it says fill in the blanks for each of the trig identities shown below. So some of them are filled, one side is filled, and you have to fill out the other. So what is sine theta over cosine theta? It is tangent theta. Yes, so let's write that down. I don't know why it's not working. Oh, it is. Tangent theta. Secant theta is what? It's a reciprocal of cosine theta. Cosine over sine. Tangent is sine over cosine. So cosine over sine will be what? Cotangent. Oh, I went down. Cotangent theta. And cosecant theta is 1 over sine theta. So here, these actually are also called the Pythagorean identities. They come from your a square plus b square equals c square, right? I'll just quickly tell you. A square plus b square. If you had a unit circle, what's the equation of your unit circle? Going back to your equation of a unit circle, it's x squared plus y squared equals 1. If I was to write this in terms of sine and cosine, isn't x cosine square and y, I can say cosine squared theta 1 to 2, yes, and sine squared theta equals 1. And that's one of our number 4 is that sine squared theta plus cosine squared theta is equal to 1. They actually all come from this. If I divide this whole thing by cosine squared theta, what do I get? I get this number 6. So cosine squared over cosine squared is 1. Sine squared over cosine is tangent squared theta, and 1 over cosine is what? Secant squared theta, right? And if I divide it by sine, what do I get? Cosine over sine is cotangent. Sine over sine is 1, and it's just like reversed. So that's where these identities come from. That's what's a quick way of remembering them. That's easy to remember, and you don't forget them. The other thing you can do is the cos go together. 1 plus cotangent is cosecant. Sine squared plus cosine squared theta is 1. That is easy, and then you're left with tangent and secant. So, and this is 1 over tangent is cotangent theta. There are multiple ways of remembering them. I find, like, just writing this out, cosine squared theta plus sine squared theta equals 1, that Pythagorean identity, and based on that I can find out the rest. So let's start with our lesson. Our lesson is simplifying expressions using trigonometric identities. So one of the most common uses of the trigonometric identities is to be able to use them to simplify more complex expressions. That's where you need them, to simplify more complex expressions. And as we go along, we'll see more and more of them. So the first one it says is simplifies this expression. I always tell you that to write everything in terms of sine and cosine. It's so much easier. Unless you know an identity, that could be replaced, but for most part that works. It's already written in terms of sine and cosine, and how would you simplify it? I see sine common in both of them, so let's factor out sine. Just go with your instincts. Sometimes it might not lead you to the right answer, but you will get something, and you'll, like, the more you practice these, the better you get. So this is what? Cosine square x minus 1. What is cosine square x minus 1? Isn't that same thing as negative sine square x? Yes. So, again, this is one way of doing it. You have to have the same, add the exponents, so you have negative sine cube x. That's it, right? So let's do example 2. Our example 2 is simplify this. So again, I'm going to, if I know one of the identities, I can use that, which I know. Secant square x is what? 1 plus tangent x. Hold on. Where is my pen? Secant square. Example 2. So it says simplify this expression. So again, either you can write it in terms of sine and cosine, and then you'll have more work. You can do it like that. But I also know my secant square x is what? 1 plus tangent x, or tangent square x. So I'm going to replace with secant square x this with 1 plus tangent square x, right? Minus 1 over sine square x. So now what do I know? The ones cancel out, right? What is tangent square x? Isn't tangent same thing as sine square x over cosine square x, right? All over sine square x. This becomes your complex fraction, which you do keep change flip, so you left with over cosine square x times 1 over sine square x. The sine squared x's cancel out. Some of you can see it up here also, then it'll cancel it out here. That's fine. You don't have to show that extra step. What are you left with? 1 over cosine square x. 1 over cosine squared x is what? Secant square x. So I want you